Hello, I am Rajit Shah. I work in Big Data team in VMware R&D. Today in this video, we'll see how to make Hadoop clusters elastic. What is elasticity? We should do data and compute separation. Keep task trackers and data nodes are in different VMs and decommission task trackers if there is a resource contention and recommission task trackers if some Hadoop jobs are running, we need more resources and there is no resource contention in the whole system. There are two different ways to create elasticity. One is manual elasticity. How many task trackers should be active in a Hadoop cluster, setting a target compute node number. There is another kind of elasticity which is called auto-elasticity, which means automatic VHM algorithm determines how many task trackers will be active in a given period of time, depending upon priority and available resources in the whole system. Automatic recommission and decommission of task trackers will be happening by this algorithm. While doing the recommission and decommission automatically, it also maintains one policy by setting up minimum compute node number. This policy says like at any point of time that minimum compute node number will be maintained in the cluster. Now we will see how to create a data compute separate cluster and how to make it elastic. Let's start creating a data compute separate cluster. Let's choose data compute separation cluster and it will give us a format which says it has one data master which is name node, one compute master which is job tracker, one data worker group which has 3 data nodes, one compute worker node which is having 6 compute nodes which is 6 task trackers, and one Hadoop client. And these are the default configuration, but we can always change by changing small, medium, large, or you can customize. So we can change the vCPU number, memory size, storage size, and data store type. But I'm keeping this all default now. And I wanted to create the cluster inside a top level resource pool called Big Data RP. And I will click on OK. I have created two clusters. One is Elastic Hadoop 1 and another is Elastic Hadoop 2. Both are data compute separation cluster and both of them are created with 12 VMs, 6 compute VMs and 3 data nodes. After creation, you can see the elasticity mode of those clusters are manual. Now we will see the status of two newly created cluster in Serengeti CLI. So if you see in my command, cluster list shows two clusters created, Elastic Hadoop 1 and Elastic Hadoop 2. And for newly created cluster, the elasticity mode is disabled and minimum compute node is 0 and target compute node is not applicable. So this is the default behavior of a cluster after just creation. Now we will change the elasticity modes and their parameters from WebUI as well as in the Serengeti CLI. Let me go to Elastic Hadoop 1 and now it's showing the elastic mode is manual. And let me see how many task trackers are active now. Map reduce status page, and if you see now it is having 6 nodes active and that is the number of nodes we have provisioned. So now I will change the target compute node. So let me put a target compute node as 3. So after changing that elasticity parameter target compute node, we can see 3 compute VMs is powered off. Let me go to job tracker status page. 3 task trackers are active. Now we will change the elasticity mode of Elastic Hadoop 1 as auto. So I'm choosing elasticity mode as auto and I'm choosing minimum compute node as 4. Now we can see that as we have changed the cluster elasticity mode as auto and we have given mean compute node as 4. So it has recommissioned one compute VM to make the 4 task trackers active all the time in the cluster. So now we have only 2 compute VM as powered off and all the other compute VMs are powered on. Let us go back to job tracker status page and it will show how many task trackers are active right now. Now we will see how to change the elasticity mode and elasticity mode parameters in CLI. So in CLI we have a command called cluster set param. If you do the cluster set param, it will show what are the parameters. It takes name, elasticity mode, mean compute node number, target compute node number, IO shares, and those kind of stuff. Now I will change the elasticity mode of Elastic Hadoop 2 cluster with manual, and the target compute node I wanted to change as 1. So this is the command I'm using. So cluster set param hyphen hyphen name, the name of the cluster, and the elasticity mode as manual, and target compute node number as 1. So now it will take some time to make that happen. Now I will change the elasticity mode of Elastic Hadoop 2 as auto. To do that, I will use this command cluster set param hyphen hyphen name, the name of the cluster, and elasticity mode as auto, and I will give the min compute node as 0 this time. So it's pretty quick and it is being adjusted. Now we will see what is the status of this cluster. So if I go on the top, it shows the auto elasticity mode is enabled. It has min compute node as 0 and it has target compute node as 1. And if you see the compute VMs, I can see only one compute VM is powered on and service ready and all other are powered off. So this is how we basically change the elasticity modes in WebUI as well as in CLI. Now we will see the effect of auto elasticity. So to do that, I made some adjustment to the two clusters. Both the clusters are in auto mode and both the clusters are having minimum compute node as 0 and target compute node as 1. So that both the clusters are starting with one compute node as powered on, or you can say one task trackers are active each of the clusters, and then we will run some Hadoop job and we will see as Hadoop job is running we need more resources, so auto VHM will power on compute VM one after another every 5 minutes. So let me start a PyJob in Elastic Hadoop 1. As this PyJob has been started, now we will monitor like how the compute VMs will be powered on by auto VHM in this cluster. Now it's only one compute VM is powered on. Now end of the expansion experiment, we can see in Elastic Hadoop 1 cluster all the compute VMs are powered on. I can see all the 6 task trackers are active right now. At the same time, if I go to second cluster 2, I can see only one compute VM is powered on. Before starting the second experiment of shrinking, let us discuss about why this expansion happened. So if you see the BD 1.0 Elastic Hadoop Cluster 1, we have all 6 compute VMs are powered on and all the task trackers are active. And if I see the CPU utilization of all these compute VMs, we can see over that time almost 100% CPU utilization happened for all the compute VMs. To fulfill CPU requirement, AutoVHM expanded all the VMs one by one, and whereas in the second cluster there was no CPU utilization and there was no CPU requirement, that's why no expansion happened by AVHM. Now we will do the second experiment to demonstrate shrinking. To do that, I have started PyJob in both the clusters. And in both the clusters, this PyJob will try to capture 100% CPU, and both of them will try to utilize 100% CPU of the whole system. So in that case, there is a competition for CPU in both the clusters. Now in this case, VHM algorithm will try to adjust the requirement for both the clusters, and it will do some shrinking and some expansion so that the whole system reach to an equilibrium. Now if I see the compute VM state, in cluster 1 I can see one shrink, and in cluster 2 I can see two expansion. So in that case, like as more CPU utilization is happening in cluster 2, we can see the expansion, and as this CPU is shared from like cluster 1, we see the contention in cluster 1. That's why VHM has shut down one of the compute VM or like decommissioned some of the task trackers. While these two experiments were running, I plotted some graphs in background, and that will show us the conclusion of how your Hadoop clusters have become elastic. So both the clusters were in auto mode, and the shrink and expansion was completely controlled by automatic VHM. So in the first experiment, we ran some PyJob in Hadoop cluster 1, and that's why we have seen expansion in every 5 minutes almost. And in that period of time, there was no job was running in Hadoop cluster 2, so there was no expansion, even shrink. So at this period of time, Hadoop cluster 2 started running some job, and that's why it needed more resources, and VHM actually expanded this cluster. When the expansion happened in Hadoop cluster 2, then Hadoop cluster 1 felt some contention. That's why VHM made some shrink in this cluster, and gradually both of them were reaching to one particular equilibrium point where both the clusters actually settled down. Then after we ran some other workload, and that's why we see a lot of shrink and expansion in both the clusters. So that's how big data extension make your Hadoop clusters elastic.